Good morning. Actually, it's night time. Mind. So, today we have landed upon a really trivial question. Why do textbooks mostly use a hinge support and a roller support in UDL and uniformly varying load questions? Now, if you may not have noticed, many textbooks, in fact, almost all of the textbooks, use a simple hinge support at one end and a roller support at the other end of a UDL question. And same is the case for our non-UDL questions. Why is that? To understand this, first we'll have to jump back to the basics that about what is a movement, what is support, different types of support, and then we'll finally able to answer our question, why always do we use hinge plus roller support? So what is a movement? Well, you might think that, oh, this is really easy question to answer. But to define movement is really trivial. So I want you to understand it like this. If Earth's center was our origin, any change in a body's position or orientation about the origin is movement. And as we know, the Earth is flat, of course. So any change in position of a particular body or any change in its orientation about any of the axes will be defined as movement. As simple as that. Um, and as we all know, there are 6 degrees of freedom. What is degree of freedom? Way in which movement is possible. So the 6 degrees of freedom are if the x-axis is y-axis and the z-axis, 3 translational degrees of freedom about in x-axis, in y-axis, and in z-axis, and 3 rotational degrees of freedom about x-axis, about z-axis, and about y-axis. So there are 6 degrees of freedom in our universe if we neglect vibrational degrees of freedom. Let's not get into that. Degrees of freedom is equal to 6. Alright, so there are 6 possible ways in which a body can move. So now let's get to the next question. What is a support? What exactly is a support? Now I want you to wait for a second and ponder on this question. What is a support? Try to define it. Well, you may say that my grandpa's stick is a support. But no, that cannot be defined as a general definition. So actually, support is anything which restricts movement. Support is anything which stops movement. So, in a way, can we also define brakes as support? Well, we'll have to think more about that, but let's get it for now. So, um, anything which restricts motion or degree of freedom is support. Let's just write it over here. Restricts movement is support. Now we have different kinds of support in civil engineering. There are mainly 3 types of support. The first one, types of support. first one is a roller. As the name suggests, it is just uh, two tires or a single tire on which our load is rested upon. As you can see, this tire would allow this beam. Let me draw a better diagram. Okay, and just take a white marker. As you can see, this tire would allow this beam or this rod to travel in X direction and would also allow the rod to rotate about Z direction. But this would not allow the rod to go down, right? Because the ball would stop it. Actually, the diagram is something like this. Just to explain the rotation better, I use this diagram, but actually the diagram is this. So motion in y direction is not possible. We are not considering z direction as we are only concerned with 2D diagrams over here, and translational motion in x direction is possible and rotation is possible. So roller support only restricts one type, one type of motion. And now you'd ask, how would it restrict motion? It would restrict motion by applying a reaction force. Applying a reaction force. Yep, I just misspelled force. Anyways, so if a roller is restricting motion in vertical direction, then I think it's obvious that it would be applying a reaction force in vertical direction to stop that motion, which is the reason why any kind of roller can be transformed into a vertical reaction force in a free body diagram. This point is A, we can write it as reaction force at vertical reaction force at A. Alright, now let's jump. We are done with roller. Now let's jump to the second type of support, that is hinge support. Hinge support is basically depicted as triangle. We'll not go into depiction. That's the job of your boring professors. Uh, irony. Now, as you can see, hinge support stops motion of a rod in x direction and also in y direction. Like you cannot push this rod over here. This hinge would stop it from going left, and it cannot even go up. So hinge only allows our rod to rotate about its axis. And as I had priorly explained, to stop a motion, we must apply some kind of restricting force, that is reaction force. So in case of hinge forces, its free body diagram can be replaced as a vertical reaction force because it's restricting movement in vertical direction, and also a horizontal reaction force because it's stopping movement in horizontal direction too. We are done with this. Now our last type of support, that is fixed support. As the name suggests, and I guess you would have probably guessed it by now, hinge support is basically a type of support in which all the degrees of freedom are restricted. It's basically depicted by this wall. Now, as you can see, this wall would not allow horizontal translation of this rod, neither the vertical translation of this rod, and nor the rotation of this rod. So, to stop a movement, yep, we'd have to use a reaction force. So this would be vertical reaction force to stop the vertical movement, horizontal reaction force to stop the horizontal movement, and a reaction movement movement to stop the rotation movement of this rod. Right. So if I have to write, I can write number of reactions by a fixed support R3 by hinge support. There are two, and by a roller there are one. Now we can finally get back to our question. Why only hinge plus roller? Alright. To understand this, we use all the types of basically three types of uh, combinations that would easily explain why we use this and also why we are not taking more examples. First one would be a roller, actually a hinge and a roller, the convection, the myth, the legend. The second one would be one hinge and second hinge, and third and my favorite example would be two rollers on a single load. I love this example. Okay, let's get here. So if we take this diagram and we apply a purely vertical force on it, just a second, purely vertical force on it, how about I replace these symbols with reaction forces instead? Alright, this is my purely vertical force F. Hmm. Now suppose now if this F is pushing down on this beam, definitely this beam, one of these two possibilities can happen. Right? Let me just clear some space. If we push down on this beam, one of these two possibilities can happen. Either our beam, let's just copy this beam. Either our beam would get elongated, just a second, uh, would get elongated like this, elongated, or you can say uh, bent. And if it's getting bent, it's definitely getting elongated because earlier it was straight, and the shortest distance between 2 points is a straight line. Now it's not straight, so it's definitely longer way. So this rod has elongated. Either this rod will stay elongated, or the second possibility is this rod would elongate, but then this roller would run over here because of these elastic force and get the rod back to its original length. Uh, Now, as you can back to its original length. Now, I'd want you to wait for a second and think which one of these two would happen. You guessed it right. This is the one that would happen. The roller would run over here because of this elastic forces, thereby stopping elongation of this vein and not bending it overall. All right. So let's jump to the next example. If we use two, actually, there's even one more point that I forgot to mention over here. If we notice carefully, here RHA would be equal to 0 because F sigma f of x would be 0 as the entire rod is in equilibrium and only RH is the horizontal force. So RH will be 0. Now let's jump to hinge forces. If we make a free body diagram, this would look something like this. Right, let me just make a quick free body diagram. Now RHA, RVA, RVB, RHB. Now if we take the horizontal forces to be 0 over here as the rod is in equilibrium, RHA would be equal to RHB. Now, this is a really arbitrary equation as we cannot get to a single fixed value for A and RHA and RHB. There are infinitely many possible combinations over here. And next thing is if I uh, am I audible? Yeah, actually my headphone died over there. Yeah, if I apply a purely vertical force on this beam, what do you think? What can happen now as both of these are hinges and not roller? Yep, you are right. This is the possibility that can occur. This cannot occur because hinges cannot move. So the beam or the rod will eventually elongate, and we don't want that. Right. And the next one, if we go to the rod with two rollers, this is actually basically a skateboard, a rod and two wheels. That's a skateboard. So if we use the skateboard and apply a purely vertical force on this thing Would actually it would be difficult to guess for this one because yeah, actually this one would move. It's not very trivial. This one would move because if a rod gets elongated like this, it will the elastic forces will pull our rollers inwards to get back to its original shape. So it's not trivial, but this thing is basically a skateboard, and we can't use this in buildings, or else one day you'll be in India, next day your dad farts and you are in Pakistan. Not a bad place, but they already never mind. So we can't use two rollers in a single building. Also, if the force was a bit inclined, this would actually be served as a skateboard. So this is the reason why we use hinge plus a roller. If I have to conclude, 2 points why we use hinge plus roller are we can easily conclude horizontal forces, conclude or calculate anything would be fine. Horizon, oh, I suck at spellings. Horizontal forces, as they are not infinitely, as not infinite many combinations possible, and no elongation of rod. That's it for today's video. Thank you.